This research focuses on resolving the three major problems faced by aeronautical engineers in any space exploration mission. The problems are thermal insulation problem, challenge of extreme temperature variation, and weight concern. So basically this research will focus in looking for a material that is best in resisting high temperature and is also effective in controlling high temperature variation. The material should also be light in weight so that it can resolve the weight constraint issues. There are few materials which stands on all the parameters, and one of them is the use of aerogel. Aerogels are material comprising of all the properties such as lightweight, low density, and highly insulating. Hence, it stands out to be the most effective material that can resolve this issue and can be used for any space exploration missions. Technical definition for aerogel seems confusing, but aerogel can be defined in most simple words as a solid material of extremely low density produced by removing the liquid component from a conventional gel. Here we can look at some of the features of aerogel which depict its lightweight and highly insulative properties. Now, talking about the aerogel history, aerogel was invented by Dr. Samuel Kistler in 1931 at the College of the Pacific in California. It is said that the invention was a result of a competition between Kistler and fellow scientist Charles, who wanted to see if they could replace the liquid inside of a jelly jar without causing any shrinking. Later, in 1982, NASA finally adopted aerogel as its insulating material for its space exploration mission. Even now, the traditional silica-based aerogel have been successfully used in many space applications such as providing insulation in spacecraft and also insulation in buildings when used in a blanket form. Production of aerogel can be done in 5 steps as follows: preparation of silica salt, gelation, solvent exchange, supercritical drying, and post-treatment. The following preparation can be well explained through the next diagram. Triethyl orthosilicate solution in the presence of ethanol and HCl as a catalyst on mixing results in the formation of silica oxide sol. Tributylene solution in the presence of ethanol and acetic acid as a catalyst results in the formation of titanium oxide sol. Mixing on both the sols results in the formation of SiO2 TiO2 sol, which, on allowing it for settle down, results in the formation of beads known as alcohol-gels. These alcohol-gels, after separating from the solution and allowing it for supercritical drying, results in the formation of aerogel beads. Commercially, aerogels are made using two techniques: alkoxide technique and water glass technique. Alkoxide technique consists of 3 steps: hydrolysis, water condensation, alcohol condensation, while water glass technique consists of hydrolysis and water condensation. Alkoxide technique. Hydrolysis. In hydrolysis, methoxy group is removed and hydroxy group is added to the silicon, which results in the formation of silanol group. In water condensation, the removal of H2O group from the silanol results in the formation of siloxane bridge, while in alcohol condensation is the removal of alcohol. In this case, the alcohol is methanol, hence the removal of methanol group from the silanol and methoxysilanol group results in the formation of siloxane bridge. Water glass technique consists the use of sodium silicate. So, at hydrolysis step, sodium is removed and hydrogen is added, which results in the formation of silanol group. This silanol group, on water condensation, results in the formation of siloxane group.
Now we will discuss the application of silica aerogel in aerospace engineering. There are many number of applications present, but as we know our problem, which is about reducing thermal insulation, extreme temperature variation, and weight constraint in space exploration mission. To solve this problem, there are 3 major applications of silica aerogel are there. there. First one is thermal insulation, second one is thermal barrier, and third one is in manufacturing for spacesuit. Let's start with thermal insulation first. Since aerogel have low electrical conductivity, NASA expanded its research into thermal insulation. Silica aerogel was first used as an insulator on Mars rover Sojourner as part of 1997 Pathfinder mission.
Aerogels are being studied in manufacturing of spacesuits. There are 6 extravehicular mobility units: liquid cooling and ventilation garment liner, liquid cooling and ventilation garment liner outer layer, liquid cooling and ventilation garment liner water transport tubing, pressure garment blader, restraint, thermal micrometeoroid garment liner. Advances in material science and engineering. We have discussed the application part of aerogel. Now we will discuss the cost analysis of aerogel. The key factors in determining the cost of aerogels. First one is materials. Now here's a table that shows different input materials with their respective cost for the manufacture of aerogels. The other key factors are energy, manpower, facility cost, and equipment. Conclusion. Although only an initial economic analysis, the cost of starting material has been identified as the major factor in the overall cost of the manufacture of aerogels. Further development in the use of inexpensive precursors will hasten the deployment of aerogels in the commercial marketplace. Market demand. The silica aerogels market is global, with significant growth in North America, Europe, and Asia. In Asia, rapid industrialization and increasing infrastructure development are fueling demand for this material. From this graph, we can see the demand of aerogel used in various materials.